afternoon to the second breakout session. We had this yesterday, this concept, and we're doing it again today, which is called Point, Counterpoint. And the whole idea of these sessions is not to have a debate, so that's not what it is. It's not one presenter against the other. The whole idea was to present topics that there be either some controversy to, or individuals are hearing different things and really don't understand the background on why is there such a difference of opinion in these two sides. So yesterday we did, is a calorie? Does it really matter what you eat if it's all calorie balanced? And today the topic is genes versus environment. And I think the bottom line, just to get ahead of it, is it's kind of both. But what they're going to be presenting is the evidence and the data behind both of those, so you can start seeing what the difference is in the thought process of that. So the two presenters are, the first one would be Dr. Donna Ryan, who's Professor Emerita at Pennington Biomedical Center in Baton Rouge, about an hour from here, where she's directed clinical research for 22 years. Dr. Ryan's continuing research includes a focus on translation of effective weight management into primary care practices. Her scholarly activities include authorship of more than 200 original publications, including the obesity guidelines that we've talked about a lot at this conference, and 45 books, chapters and reviews, primarily in the field of obesity. She's also editor-in-chief for the journal Obesity, and also is speaking as Dr. Peter Katzmarzyk, who's a professor and associate executive director for population and public health sciences, also at the Pennington in Baton Rouge. Peters is internationally recognized as a leader in the field of physical activity and obesity, with a special emphasis on pediatrics and ethnic health disparities. He has more than 2 decades of experience in conducting large clinical and population-based studies in children and adults, so welcome both of you. And I think Donna's going to go first and talk about genetics, and then Peter will go after that and talk about environment, and we'll have time for Q&A after that.
Great, thank you, Bob, and thanks to this very committed and loyal group of people who showed up for the last talk of the day. Thank you so much. So yeah, my side of the discussion is really to focus on genes and which impacts weight more, genes or environment. These are my disclosures, and let's talk about the beginning of our interest in genes and their association with body weight. So I want to really emphasize how important the discovery of leptin was in 1992. And we had known that there were strains of animals that were genetically obese. And the most famous of these strains was the OB mouse. There was another strain called the DB mouse. And we had known about these strains for about 50 years, and we had done a series of experiments that illustrated that there was something genetically wrong with these animals called parabiosis experiments. Now, I'm not going to get into the parabiosis experiments because I can guarantee that I would give everyone in the room a headache trying to understand these experiments. But I really want to put this out there as the beginning of our understanding that there was more to the regulation of body weight than just willpower and being able to control it. So the OB mouse had a genetic defect in the production of a protein called leptin, and the DB mouse had a genetic defect in the receptor for that protein, that leptin receptor defect. So there were 2 strains of animals that led to the important discovery of this protein called leptin. Leptin is important. It's important because it really provided evidence of the biologic basis of body weight regulation. Before that, the discovery of leptin, I think it was far too easy to think that, oh well, we could just control our body weight if we wanted to. We just had to have enough willpower to be able to eat less and exercise more. So leptin was really opened up a whole field of discovery. So leptin is a protein. It's produced by body fat. And its chief function is to send the brain a signal as to what body fat stores are. Leptin has a lot of functions, but its primary function is to signal starvation. So when starvation begins and body fat level falls, leptin level falls, and the brain recognizes this fall in leptin, and it causes there to be an increase in food intake and a reduction in metabolic rate to conserve energy. So it's the brain's natural response to starvation. Now, leptin levels vary exponentially with fat mass. It's a pretty good surrogate for the amount of fat mass that a population has. So individuals who have excess body fat have very high levels of leptin. Something has happened to that regulatory system where increases in leptin are not being perceived by the brain to produce a reduction in food intake and an increase in energy expenditure. This system was not designed to keep us all skinny. This system was designed to keep us from starving. So that's the evolutionary purpose of this leptin molecule. So we have identified some individuals who have leptin deficiency. They're very, very rare. And we were fortunate enough at the Pennington Center to study 3 of them. And here's a picture of them. They're cousins from Turkey. And they all had really a lot of excess body fat, and their excess body weight and body fat began in childhood, and it persisted throughout adulthood. So they were given human recombinant leptin. So we identified the genetic defect. They had a single gene mutation, a single amino acid mutation in this gene. We gave them the normal human leptin by injection. It's a protein. It has to be given by injection. And after 3 months of treatment, look, they've already begun to lose body weight. And at 10 months, they had lost half of their body weight. They were reverting to normal. They weren't on some sort of fabulous intervention that we were giving them. They weren't even trying to diet. They weren't trying to increase physical activity. They lost weight because this signal that had been missing from their body was being given by injection. So of course this caused a flurry of interest among the scientific community. And we all thought, oh, hallelujah, we've got something, we've got a new treatment for obesity, and we're going to be able to help all of the people in the United States, we're going to be able to help all the people in the United States lose weight by getting these leptin injections. So Amgen developed leptin as a potential treatment. Did it work? No, it didn't work. Even at very, very high doses, weight loss was very minor. And when you had to give those high doses by injection, it caused a lot of injection site reactions, like redness, soreness, really terrible reactions to this protein. So it was not going to work in ordinary garden variety excess body weight obesity. Leptin has been used in the clinic, but only in rare instances where there's leptin deficiency, and there are less than 50,000 people with this in the entire population of the world, which is 9 billion. So in the rare cases where we identify leptin deficiency, and in this condition called congenital or acquired lipodystrophy. And so when there's this abnormality of body fat, we can give leptin and reduce some of the symptoms of that. But that, again, is a very rare occurrence. So leptin hasn't worked out as a treatment for us. There are other single gene defects out there that have taught us a lot about obesity. And there's some genetic syndromes. I know many of you have probably heard of Prader-Willi syndrome, which is not unusual, and it occurs in children. And these other genetic syndromes, and then single gene defects in the melanocortin-4 receptor and the POMC, the pro-opioid melanocortin receptor gene. So it's thought that in children with severe obesity, we're talking about 3, 4, 5, 6-year-old children who have really extreme obesity. We think that about 5% of these kids actually have one of these genetic defects in either melanocortin-4 or POMC. And there's a new drug that's coming out called setmelanotide, and it's being developed to specifically address melanocortin-4 receptor and POMC genetic defects. So there's a big study underway to try to identify these children and young adults who have this genetic defects, because it appears that this drug treatment is going to be very specific for that single gene defect. So I'm showing you here on the left panel, 2 patients. So this is overlying a growth curve. And so we see the 97th, the 90th, and the 50th and the 3rd percentile plotted there. And then in red, the weight of patient 1, and in blue, the weight of patient 2 over age 1 to age 18. And you can see that the onset of excess body weight started very early in these 2 individuals and continued to progress to severe obesity. And then the panel on the right, on the top panel, I'm showing you patient 1 who was treated over about 42 weeks, and patient 2 who was treated over about 12 weeks with this setmelanotide. So the weight is shown in red in the top panel and in blue in the bottom panel. And we see with the introduction of this agent, there's a reduction in weight. Now those bars, those gray bars, are hunger scores. And so we see as soon as the drug is started, we start seeing a decrease in the hunger scores that parallels the weight. Then, if you look at patient 1, there's an increase in hunger scores that occurs at about 14 weeks. And at that point, the dose of the drug was increased because the weight was going up, and there's then again a decrease. So over about 42 weeks for patient 1, there was loss of over 120 pounds. Really an incredible turnaround. And in patient 2, over just 12 weeks, there was loss of about 45 pounds. So identifying a specific genetic defect in these rare cases of individuals can result in specific targeted therapy. Do I think setmelanotide is going to make it out into the general treatment of all of my patients? No, I don't. I think it's a highly specific targeted therapy. But we do know that there's a genetic background that occurs with obesity, because we know that parents with obesity are more likely to have children with obesity. And this is a study that shows that parents with obesity, and those are shown here in the triangles, that parents with obesity, that the offspring of those parents are more likely to be obese than offspring of parents without obesity, whether or not childhood obesity existed in those individuals. So we know that there's a familial component to risk for being overweight and obese. And to me, the strongest evidence for this is the twin studies. So first I want to show you fraternal twins. These are twins that share 50% of the same DNA. They're living in the same environment, of course, because they're in the same families. And then I want to show you, these are identical twins. They share 100% of the same DNA and are living in the same family. So the identical twins on the bottom, I want you to notice, we know this about identical twins. They have the same hair color, they have the same eye color, and look at the amount of concordance, how identical their body shapes are. Their body habitus is the same between each member of the pair of identical twins. And look at the top. Look at how much discordance there is in these fraternal twins. So these twins are sharing 50% of the same DNA, and there's a lot of discordance between body habitus in these fraternal twins. So this says to me that there's an enormous amount of genetic input into our body size. And indeed, there are more than 200 genes that have been associated with BMI and 100 genes that have been associated with waist circumference. So some of these genes are common variants that are out there, and they're associated not with the risk of storing excess body fat, but also where that body fat is stored. So this is a study where these are genes that are important in the regulation of food intake in the brain. And they're looking at 15 or so genes in a large sample of the population. And you can see that there's a bell-shaped distribution of these genes. Some people have very few, a few people have very few, a few people have very many. Most people have an average number of these genes. But in gray, what we've done on here is plot the BMI, the average BMI for each of these categories. That shows that as you accrue the number of these genetic variants, the BMI goes up. So these are common risk alleles that occur in the population. And it's kind of like the deck of cards is dealt out when our genes are inherited from our parents. And you can get a royal flush of genes that are going to put you at greater risk for excess body fat within a given environment. So we know that there are variants of single genes that occur commonly, over 200 associated with body mass index, over 100 associated with waist circumference. Each one of these contributes only a small amount to risk for excess body fat, but in aggregate, the risk can be great. The most famous one of these single gene variants is probably what we call the FTO gene. Well, the FTO gene by itself only incurs a risk of about 6 pounds excess body weight. But there are 200 other of these genes out there. And when each one is contributing a small amount, taken together, they can really increase the risk for developing excess body fat within a given environment. And then it's not just the genes that we were born with, it's how those genes are expressed. So we know this whole factor of epigenetic influences on our genome. So we know that especially in uterine environment and early in after birth, that there are changes that can occur to the genome that are fixed, that can influence how our genes are expressed and can determine risk for overweight and obesity. So we know that in utero, in fetal life, if there's undernutrition, or if there's overnutrition, if there's excessive weight gain, or if there's fetal deprivation, both of those things can increase risk for obesity in later life. So we have this U-shaped relationship where undernutrition and overnutrition can both contribute to the expression of genes that then results to chronic diseases like obesity in adulthood. So not only do genes influence our risk for becoming overweight or obese, and where body fat might be stored in us, and thus contribute to our risk for the chronic diseases associated with obesity, but our genes can also influence our response to therapy. We know there's individual variation in weight loss, even with identical energy deficits. So how we lose weight can be genetically determined. There's individual variation in this metabolic adaptation, that reduction in metabolic rate that occurs with weight loss. It's not the same in every individual. And we know that there's individual variation in response to different medications that we're giving to help aid with weight management. And also, this is really something that's not much talked about. There's a lot of individual variation in the amount of weight one loses with bariatric surgery. So Tim Church talked a little bit about this yesterday. And this shows the weight change that occurred in 16 months of supervised exercise. We were absolutely certain all the patients were getting the same dose of exercise. They were allowed to eat ad lib. There was no dietary modification variation in this. But this shows weight change. And for men, most men lost weight, but variable degrees of weight. You can see that in the panel on the right. For women, about half of the women actually gained weight with the exercise program, but it came this enormous variation in response. Well, even when we're trying to maintain caloric intake the same among all individuals, we see the same amount of individual variation. And that's illustrated in this study that was done by my boss, Claude Bouchard. And he took 7 sets of twins, so 14 individuals comprising 7 twin pairs. And he put them on an exercise program of cycling. And they had to do it 9 out of every 10 days. It was a 93-day intervention, so roughly 3 months. There was constant personalized energy intake where the caloric intake was fixed. The average weight loss was 5 kilograms. So you can see the pre-weight and the post-weight illustrated in the figure, and there's a reduction of about 5 kilograms. That's 11 pounds. But those error bars give you an idea of the individual variation that occurred around the weight change, even though he was trying to hit the same amount of weight loss for every single person in the study. And the twin pair part comes in here, because what we've done is we've plotted the change in weight for each twin in the pair. And the more alike the twins are within the pair, the closer those dots are to the line. So what it shows is that there might be variation between the twin pairs, fairly wide variation, but within each twin pair, there's very little variation, which would suggest that the genes are very important in determining the amount of weight loss response to exercise. This shows you the variability of metabolic changes after weight loss. And we're looking at a reduction in total energy expenditure. This is the residual reduction. So this is the difference between the reduction that would occur with just it being at a reduced body weight. And so it's that effect on metabolic rate that's caused by this metabolic adaptation changes of weight loss. So on average, it's 345 calories a day. But look at the amount of individual variation. So I know we talk about the challenge of metabolic adaptation, but it's not the same for every individual. This is a biologic response, and my bet is that it's very much genetically determined. Even when we do our studies with lifestyle modification alone, shown here in gray, or with medication, here I'm showing you 2 doses of medication in green and purple, we see this large amount of individual variation. Now this can't tell you whether that variation is genetic or not, because we haven't done the studies of this. But I believe that a part of this is genetic. And to show you why I think that, I'm going to turn to the amount of variation in weight loss after bariatric surgery. So here we see this nice bell-shaped distribution of the amount of excess body weight loss that occurs after bariatric surgery. So I know we talk about, oh, well, with Roux-en-Y bypass, we get 35% body weight reduction. That's average. That does not tell you the range. And there is variation in response to these procedures. I'm going to show you why I think that it's very much genetically determined. So in that study that I showed you, the variation in weight loss response, there were 13 pairs of first-degree relatives, primarily siblings. And there are also 10 pairs of individuals who were cohabiting. They were not genetically related, but they were living in the same household. And so what I've plotted here in 3 bars are the difference in excess weight loss variation. In the first one is the first-degree relatives. It's less variation than the unrelated individuals, and the unrelated are exactly the same as the cohabiting pairs. So there's much less variation in weight loss response among members who share 50% of the same DNA, which suggests to me that that genetic variation that the genetics of this variation in weight loss response is very, very important. So, genes are important, but genes are not the whole story. I apologize for this figure not coming out right. When you get this at home, you're going to get this presentation, and these dots are not going to be elongated. They're going to be dots. And what this shows you is the rate of trends in overweight, obesity, and extreme obesity in the United States. And the yellow line is overweight. So the proportion of the U.S. population that's overweight has been fairly steady. The red line, the cherry red line, the next one down, is the rates of BMI greater than 30. And we saw an increase in that beginning in the NHANES survey, 1988 to 94. And it's continued to trend upward. And then the bottom line, that orange line, that shows the rates of extreme obesity. That's BMIs 40 and above. And we see that also beginning to increase in 88 to 94, and then it's continuing to increase. So the genes did not change in 1988. The genes did not change. The same genes in the population. But what changed? The environment changed. These genes confer risk for developing overweight and obesity. These genes also help determine response to your weight loss treatment. So the environment is very, very important in terms of development of obesity, because the genes only set the stage. The environment causes the manifestation of obesity to occur. So one way to view this is that genetic variability, the genes load the gun, the environment pulls the trigger, and the bullets do the damage. So it's the obesity itself that does the damage. And another way to look at this is that the genes are really determining the potential for development and obesity. It's the environment which determines whether and to what extent this potential is realized. So there's a complex interaction. It's not just genes. It's not just food and physical activity environment. It's many other things in the environment that are important. So it's stress, peer pressure, hormones. Maybe it has to do with endocrine disruptors and pollution. There are many other factors that are out there that determine the expression of these genes and how obesity is expressed. So that's my story, and I'm sticking to it.
Alrighty. I think as we go through this, we're going to see that Dr. Ryan and I are not that far off in terms of point counterpoint. I was asked to talk a little bit about the environment and how that may sway the evidence towards the effects of the environment on overweight and obesity. And I'll just put up my disclosures very briefly that like most scientists, I receive a variety of funding for the research. None of it is directly related to the presentation today. So there should be no conflicts of interest here. Dr. Ryan kind of set the stage talking about genetics and some specific genes that may incur risk. From my perspective, from an epidemiological kind of focus, I'm going to talk a little bit about genetic epidemiology, where we try to infer the effects of genes from large family studies and twin studies that are in real living people out in the environment. And this is one such study. Let me just set the stage. On this side, we have relatives, and on this side, we have spouses of individuals. We call them probands. That's just an individual selected at random from the population, in this case. And as this person's BMI goes up, we see that their relative's BMI also goes up. So that somebody above the 99th percentile with BMI, if probability that their first degree relative also has a BMI at that level is 5 times. So it's a standardized risk ratio, and we see that as you go towards that back corner, the risk increases. So essentially, among random individuals in the population, as their BMI goes up, we see that consequently, not consequently, but at the same time, we see their first degree relatives also having a higher BMI. The one on the left is interesting because this is spouses. And we see the same trend going on here, but it's at a lower level. So this suggests that some of that familial risk, as we say, is also related to this cohabitation. Because normally, spouses are genetically related, except in a few states, though. It's about 3.5 times risk versus 5. So we see that the difference in the heights of these bars, really is kind of maybe like the genetic effect on BMI. So that's one way to look at it. And just to kind of summarize, Dr. Ryan talked about the twin studies. Another way to get at this is to use extended pedigrees of families. Because we know, the degree of genetic relatedness among first-degree relatives, second-degree relatives, and among spouses, theoretically. So by doing that, we can actually estimate that all the family studies that have been done, essentially they point to what a 47% median in terms of the effect of genes on BMI. The twin studies always have a higher estimate, about 75%. So this suggests that between 50 to 75% of the variance in BMI is attributable to genes, but on the other hand, there is a substantial portion of that variance that is not. If you turn it around, we see that 25 to 50% of obesity and BMI and other adiposity-related traits are not explained by genetic factors per se. So the environment must be important to some degree. So looking at these specific genes, they're out there. Some of them are very rare. Some are a little more common, but they have a smaller effect. And one study among 339,000 individuals who looked at these 97 loci or alleles that were related to obesity, they showed that it accounted for about 2.7% of the variance. So although theoretically 50 to 75% of the variance could be attributable to genes, we've only been able to find the genes that explain less than 3%. So there's a long way to go still to identify those genetic factors that increase risk. And this FTO locus that Dr. Ryan mentioned does seem to have one of the larger effects on obesity and adiposity. However, an interesting thing there, that BMI effect of that gene is attenuated by about 30% in physically active individuals. So again, we're talking about genetic susceptibility. It's not deterministic. You have genes that may increase the risk of gaining weight. However, it doesn't mean you're going to reduce weight. There's still a strong component for the environment and for lifestyle. So we really only have to look at a map of the United States to kind of understand this. This is a map of the prevalence of obesity at the county level across the United States. And of course, according to that legend, the darkest parts of the map show the highest prevalence of obesity in the country. So we see this geographic and this environmental variability in the prevalence of obesity across the country. It also kind of looks like the electoral map. That's another story altogether. Now I'm going to take us back a little bit further. Dr. Ryan showed us, the last 20 years or 30 years or so of changes in BMI. This is kind of an anthropological perspective on it. If we go back over the 3.5 million years of the hominid lineage, we go back through the fossil record, and we can kind of predict the body size of our ancestors and their BMI based on the fossil record and the robustness of the fossils, as well as muscle attachments and these sorts of things. Anthropologists have estimated, BMIs of hominids. And so you go back 3.5 million years and you're bouncing along, a BMI of between 20 and 22. But then look what's happened over here. This is on the same time scale. From 1862, some early Homo sapiens, that's us, or most of us anyway. And just look what's happened in terms of the increase in the average BMI of males in the United States over that time frame. So something dramatic in our environment must have occurred to get such a huge biological change where we've been 3.5 million years in development. And in the last 50 years, the BMI has gone up like that. So there's got to be a strong role for the environment impacting BMI, in my opinion. And of course, we all realize that day to day, our energy balance is being challenged. This could be almost any city. It's probably back to roof, though. And we have both sides of the energy balance equation in terms of both food and physical activity have been impacted. And it's a drive towards efficiency. When you look back on this time scale, no other time in history have we been so efficient at extracting nutrients from our environment and to do so at such a low energy cost. And that has been driving a lot of this. So, some people call these obesogenic environments where we have food availability at every corner in terms of high density food. And this slide represents sort of the physical activity side of the energy balance equation. This role of communities in promoting activity, where we see the probabilities of being physically active or meeting physical activity guidelines based on different characteristics of our community. And they call this the built environment. In other words, what we see outside here, that's pretty built up right there. That's the built environment. This is what humans have done in the environment, and this demonstrates kind of what it has done to our physical activity levels. Now, it is complex. This is one way of looking at it. It's called the ecological model, in which we do have this, Dr. Ryan said, the biological and genetic factors are loading the gun down here, but then we have all these different environmental components which help pull the trigger. And so it goes basically from the individual level of behavior through neighborhood environments, school environments, and national and international policy environments. And they all have an effect on obesity. Now, a crux of this is that body weight is modifiable. These are data from the diabetes prevention trial, or the diabetes prevention program, where over 4 years in this sample, through a lifestyle-based program, we see significant decreases in body weight, which are maintained. It comes up over time, as most trials do over 4 years. But we do see that weight loss in some instances is possible with lifestyle interventions, even more so than using a drug like metformin. Now, what I'm not showing you is in that lifestyle group, physical activity also increased quite substantially. However, because physical activity and diet were both manipulated in that trial to produce that weight loss, it's very difficult to say which one was more important. There are some post hoc analyses that can be done to try to tease that out, but the trial was not designed to say physical activity or diet was more important. But we do know, this is some work from Dr. John Katzmarzyk with women, middle-aged women with overweight, and this was strictly a physical activity intervention of home-based physical activity over 18 months. And what we see here very clearly is a dose-response association with weight loss. Women doing less than 150 minutes lost this kind of weight in this pattern. They did at least the guidelines, so 150 minutes, they lost more weight. If they did 200 minutes a week, they lost even more weight. So we see that using something like physical activity, which is an environment and a behavioral attribute, we can change body weight and it can be sustained for 18 months. I just wanted to mention this because this is work with Dr. Robert Ross at Queen's University in Canada. And he's known for conducting very meticulously and carefully designed trials. There are clinical observations in humans. However, he gets very, very good adherence and he carefully controls the environment. These are two studies he did. The one on the left is in men, and the one on the right is in women. And let me just kind of go through this so you can see what I'm trying to say here. But over 12 weeks in men, and 14 weeks in women, he had a control group, which is in red, and we see there's no real change in their body weight over that time. They were just told to eat and exercise the same way they do on a day-to-day basis and not change anything. This next group in blue, these were people who he exercised at about 500 calories a day. So, 1 hour a day on the treadmill to moderate to vigorous activity. But what he did was he fed them. And you probably don't want to hear that, but he actually fed them extra calories of 500 a day so that they didn't lose weight. So he was able to show that, exercise 500 calories a day, but then you eat an additional 500, you can maintain energy balance. Now the real cool stuff is here. The yellow line is the dietary induced weight loss. And you see this very clearly over 12 to 14 weeks. You're meeting with dietitians and reducing your energy intake. So that's the common thing you see with the diet over that time frame. Now in green, this is exercise weight loss. So he carefully titrated their exercise to match the dietary weight loss group. And so he exercised them all at 500 calories a day, and he got identical weight loss. So this, to me, it really demonstrates that, at least in carefully controlled situations, you can get equivalent weight loss with equivalent calorie disruption. So, we often say that, exercise doesn't work as well as diet in terms of weight loss. Well, in carefully controlled laboratory studies, it does. It's equivalent. However, where it comes into practice is in real life. And as Dr. Ryan mentioned in the prior session, maybe we don't have enough time to exercise that rigorously for 1 hour a day for the rest of our lives to lose weight. And when you prescribe physical activity to real life individuals living out in the community, it's very difficult for them to meet that kind of requirement. And this is why the dietary perspective comes into play, where, diet in the real world is probably a better way to go when you want to instigate weight loss. But physical activity itself can modify body weight. So this is a very often cited model, just to show you how complex it is. On the far right is the obesity prevalence in the population, which at the proximal level is really affected by energy intake and energy expenditure. And this is where the role of genes comes in at the individual level. However, you have all these upstream environmental factors, essentially, which impact that relationship. So I think in the end, Dr. Ryan and I have kind of come to the same place in the road, and we're going to open it up to questions now. But again, it's, in my opinion, except for these very few cases in the world of these monogenic obesities that we've identified, really there's a role for both environment and genetics when we talk about obesity, but it's not just all genetics. With that, we'll leave you with our friend from down the road, and thank you.
Great, thank you, Donna and Peter. Let me just start off with a question for both of you, although maybe Donna directly and then Peter could add in. So is there who should be getting genetics? Should people do 23andMe? Who should ask for genetic markers? Is there any role to get genetics as part of a workup or in patient care?
I think for children with severe obesity, absolutely.
No, I would totally agree with that. You have a child at such a young age, extremely high BMI. Dr. Ryan mentioned this is a strong case to be made for a single gene defect.
Okay. Any questions, comments? Please, you just use microphones, easier for people to hear. Yeah.
In both of your talks, you talked about the increase in obesity over the last 50 years. Can you talk about the U.S. dietary guidelines and the low-fat influence, which cause more carbohydrate and sugar intake, which I personally think is the cause of that obesity epidemic?
We can hear from them.
Yeah. I'll say something first. So, yeah, when I was around when the first low-fat So Diet Craze came out, and it was great because there were not a lot of foods that were low-fat substituted. So when the low-fat diet came out, you could follow a low-fat diet. There weren't a lot of highly processed foods on the shelves. So if you went low-fat, it was a good way. Counting fat grams was a good way to lose weight. But then, when the modification occurred of all of the low-fat products that were out there, you were consuming a lot of energy-dense foods that were still low-fat. So that sort of screwed the whole thing up. I think, I think there are a lot of things to blame. So there's plenty of blame that we can spread around to a lot of things. I think the dietary policies are just one of them. We spent a lot of time, we still spend a lot of time on agricultural subsidies that really support a food environment that tends to promote these highly processed, energy-dense foods. So our agricultural policies are, if we really want an unobesogenic environment, we need to change our agricultural policies about what we're subsidizing, what foods are being given cost subsidies. It's not the fruits and vegetables. It's not the high-fiber fruits and vegetables. That's one part of the problem. I think it's more that than it is actually the recommendations in terms of that sort of policy things. But let me tell you, there have been enormous changes in the amount of physical activity that's required for work in the United States and for play in the United States. So this would be a good topic for next year, Bob, because Tim Church has done a lot of research on this, on what's going on with physical activity in the workplace. I mean, just incredible changes have occurred over the last 50 years. So, with automation and with changes in the workforce, manufacturing to a workforce that's doing this and doing this. So it's really incredible. There's plenty of blame to spread around.
Peter, do you want to add anything?
Yeah,
No, it's great.
Hi. One of my reasons for coming to this convention this year is I have two sons. They're 18 months apart. One of them is extremely overweight. I have fought obesity all of my life as well as my family. I have used all of the diets that are available. Of course, I don't want to put him on medications that may harm him. And there's not any bariatric surgeons that even want to consider helping him surgically wise. And so I was wondering, as far as like the genetic markers, how do you even go about, because I've had pediatricians that act like I'm a bad mother because he's so overweight. And I've gone to our children's hospital, and they don't tell me anything that I haven't already investigated and studied. So I was just wondering, what avenues are there to even having him maybe genetically tested? What I would recommend is go to the Prader-Willi Foundation, and they can put you in touch with someone who will do genetic profiling of your child. I'm not saying your child has Prader-Willi syndrome, but I don't think it does. But I think that the pediatric endocrinologists who specialize in Prader-Willi also specialized in extreme obesity in childhood and would have access to that. So that is a network of families around the United States, and that would be a good place to start. I don't know where you're from, but through them you could find the most convenient pediatric endocrinologist who knows something about extreme obesity. What do you think, Peter?
And something here, when we talk about first-degree relatives, for example, siblings, having 50% of the genes the same, that's not the way we want to say it. We have 50% of the genes identical by descent. Then we have a geneticist standing up who's going to correct us right here. It doesn't mean they have the same genes, exactly the same genes.
Yeah.
On average, they have 50% of the genes common by descent. So Tony?
I was just going to say, the Children's Hospital in Pittsburgh is like contact, and this is exactly what you do. I can give you a person's name there.
Yes, thank you. I've worked so hard on it. Thank you so much.
I'll just add one thing. Donna, you go ahead and sit down, but I want to address your question. Dr. Ryan presented data on a drug called setmelanotide, which is this targeting of the receptors. That company is set out to try to get genetic markers on children who are severely overweight, and they are offering a free kit and will analyze children free. It's Rhythm Pharmaceuticals. So if you go to Rhythm Pharmaceuticals, you could probably identify their call out to do genetic markers. They're trying to find individuals. Now, your child may not have that, but they are doing free genetic analyses. Rhythm Pharmaceuticals. Yep.
Hi. I think you all did a fantastic job of re-highlighting the complexity of this, and throughout the whole weekend we have learned how essentially nothing really works. Whether it's energy out or intake, they all have their places where they work, and particularly over short periods of time. So it's obviously an extremely complex issue. It's one that I think our general healthcare professionals don't want to, it's so complex that they really don't want to deal with it that much. So do you all have any recommendations? So I'm on the board of the OAC, and do you have any recommendations for the OAC that things we could be doing, or some things we should be looking at to help get the word out to say, this is a one-on-one type of thing, and it's very time-consuming, and I know we have to deal with reimbursement of obesity-related issues.
Yeah, I've really enjoyed this meeting also, and because it really takes a sort of broad approach to what's really going on with people who are struggling with body weight and body weight-related comorbidities. So I think what needs to happen is for there to be a general education or re-education, not just of physicians, although they're a good place to start, but I think the general public is wrong-headed about many of their ideas about what's going on with people who struggle with weight. So I think OAC is filling that role. It's filling the role of addressing weight bias and addressing it with facts. And I think that's the wonderful thing about this organization. Keep it up.
There really is this translation gap. There's an evidence gap between what we know works and what people are actually doing. And we know that in primary care, there are evidence-based strategies for weight loss that work. We know that from looking ahead and EPP and everything else. We have evidence-based strategies that work in children. And, the Patient-Centered Outcomes Research Institute now is working to work on these pragmatic trials, putting them in the community to help translate the science into practice. And I think that's another great place that this organization can help in that translation effort.
I'm a primary care physician practicing in Baton Rouge, and recently I got my board certification in obesity medicine. And what I find is it takes a lot of time. For example, talking with the patient, finding out all the complex situations that they are involved. For example, when a patient comes for the first time for the initial evaluation, easily it can take 1.5 hours. Now, you have to remember about the insurance, commercial insurance. If you see about 8 or 9 patients per day, you will be starving. You won't be able to pay your staff and all that. Especially, I'm in solo practice, and I'm very much interested in this obesity medicine. Since I have my undergrad degree in dietetics, I thought, okay, maybe this is a good thing to combine. So, in Baton Rouge, I don't think there is anybody who is working in obesity itself. Of course, there are some diet clinics like Aspen Clinic and all that. That's not what I'm talking about. Talking about teaching people exactly what they should understand, what they should know, and depending upon the educational level of the person, it takes a long time. For example, who has studied, I mean, for example, college degree and all that, especially in biological sciences, they can understand you more better. So it is a very complex situation. And also, primary care doctors like me, I cannot afford a dietitian, exercise physiologist, and all that. That all adds up unless I work with a hospital. And the hospitals, what happens is they want you to see so many patients to meet your quota. So it's kind of, I don't know what to say about it. Unless you are really interested in it. I don't think nobody wants to touch that area.
Thank you. Thank you. Jamie, just to answer, I mean, we've talked a lot about what the OAC should do, and I think you have to think of what's your best niche. And I think you guys are going in that direction between bias and stigma, helping the patient, give them a script and questions to ask as they see the primary care provider, the advocacy, the legislative support. There are other professional societies, of course, that are doing take obesity seriously and moving with the professional point. And I think it's basically in a chorus. We're all moving the ball, moving it all forward, or singing the same song, but each of us have different roles. Certainly, OAC can take on some of this other role, but because you're not in it alone.
That's right. And education is going to be very good. Now that are aiming at some roles that we're trying to, in way, bias within the provider community itself. And so we want to aim towards that. It's not just physicians, it's the provider community. I love the idea that a couple of y'all essentially have said is that and we've been working towards it for years, but being a translator between science and the population, and figuring out how to get that out. So this year we're going to initiate some work trying to do the OAC teacher, with volunteers and doing more work on a local basis, not just nationwide, but just advocacy from middle school. And so a lot of these kind of ideas are, but they are large.
Yeah. Well, we got a lot of stakeholders involved in it, as you know. So.
It gets kind of frustrating patients. And we're figuring it out just about as fast as everybody else.
I think one threat to this organization, to everyone who's solving the legitimate approaches to help manage this disease, is the threat of these unproven, ineffective, potentially dangerous approaches that are given a lot of airtime. They're given a lot of shelf space in the drugstores. You can't go on the internet without getting bombarded with some unproven therapy. And I think these really undercut and threaten the legitimate approaches to this disease. So I hope your organization will consider that as something that's important to stand up against.
Please.
My name is Deb Dobeck, and I am a board-certified obesity medicine since 2007. And I want to just dovetail on what Dr. Ryan said. I'm a family physician and then became board-certified in obesity medicine. And I think we can encourage the primary care physicians to work with specialists. And Dr. Krishner, my understanding is there's more and more of us becoming board certified in obesity medicine. And have your primary care physicians work with the specialists as a team so that we practice evidence-based medicine and we can work together in teamwork approach.
Yep.
I am from Kansas, Manhattan, Kansas.
And you're not in Kansas anymore.
And we're not. And if you want to hear the Wizard of Oz jokes, I've got them all.
Give me the one you gave me on our run. It was a good one.
All right.
Go ahead.
I ran with Bob yesterday morning, and he's a delightful man to run with. And so why did the Scarecrow in the Wizard of Oz, why was he awarded the Nobel Prize. And it's because he was outstanding in his field.